So hello everyone. So now we see this particular assignment, that is to implement the uniform cost search for a weighted graph. The problem is given that given a weighted graph, find the minimum cost path between two nodes. So we'll implement the uniform cost search to find the optimal path, and also we'll implement the BFS and do a comparison. So let us see the code and run the code. So we can see this is the graph, and we are performing say uniform cost search. The start node is our 0 marked as green, and the goal node is 9. So if we do the uniform cost search and we start the search, so the nodes explode is 10 and the path cost is 44.7. In comparison, if we do a BFS and do the start search, so here also approximately the same, nodes explode 10, path cost is 44.7. So if we generate a new graph and do the uniform cost search, 24.6 and 4, and the breadth first search almost same. So we see in both the cases almost similar output we are getting. So let us see the code now. So we generate a graph. So the graph node, it represents a single node in the graph, and we have the graph class which represents the graph of as a collection of nodes. So there is add node and add edge method. Then we have graph search GUI class, manages the GUI and handles user interactions. So we have the generate graph, which generates a random graph with 10 nodes and random edges, 10 nodes and random edges. Then we have a draw graph, which visualizes the graph by drawing nodes and edges. Then we have the uniform cost search, which implements our uniform cost search algorithm to find the shortest path from the start to the end node. Then we have this breadth first search algorithm, which implements BFS to find the path by exploring all nodes layer by layer. Then we highlight the node with certain colors, then highlight the path, final path is highlighted, and the start the search. So this is the overall. Now let us see the uniform cost search algorithm. It finds the shortest path based on edge weights, and it uses a priority queue to explore nodes in order of the least cost, and highlights explored nodes in yellow during the search. So this priority queue stores the nodes to explore and prioritized by the total cost from the start node. Initially it contains only the start node with a cost of 0. So there is a came from to track is a dictionary to keep track of the where each node was reached from. The start node points to home, and the cost so far, a dictionary to record the lowest cost to reach each node. The start node has a cost of 0. So the nodes explode. It